we're going to have a little look now at doing calculations in scientific notation. Okay, so in my first question here, I've got 3.8 times 10 squared plus 5.91 times 10 to the power of 3. Okay, so the first thing I'm going to do is change these out of scientific notation here. When I'm adding and subtracting, it makes it easier if they're not in scientific notation. Okay, so I've got 3.8 times 10 squared, so that's my 3 units there moving 2 places bigger. 3 units is going to turn to 3 tens and then 3 hundreds. So I've got 380 fitting in just the rest of the digits around that. And then this 5 units here, if I'm multiplying by 10 to the power of 3, it's going to move 3 places bigger. So it's going to go from 5 units to 5 tens, 5 hundreds, 5 thousands. So I'm going to have 5,910, just fitting in that 91 right next to it. And we need a little placeholder 0 there. Okay, and now I can just do a chimney sum. Okay, 5910, add on 380, and I'm getting 0, 0, 0, 1 and 8 is 9, 9 and 3 is 12, 1 and 5 is 6, 6, 2, 9, 0, and I suppose it's polite, if they're putting their question in scientific notation, I'm going to put my answer in scientific notation. So I've got 6.29 as my number between 1 and 10. And those 6 units would need to move 1, 2, 3 places bigger to turn into 6 thousands. So I need to multiply by 10 to the 3, moving things 3 places bigger. Okay. See if you're Scottish and you're watching this, because you've got your Nat 5 maths coming up and it's got scientific notation in. Scientific notation questions seem mainly to turn up in the calculator paper. If you are doing scientific notation questions on a calculator, my one piece of advice to you is put every number in scientific notation into brackets on the calculator, okay? If you've got a really good calculator, in this case, it won't make a difference, but in some cases, it absolutely will. If that was a divide, it would make a huge difference if you didn't have your brackets in your scientific notation, okay? So just always put scientific notation numbers in brackets if you're doing things on a calculator. And I'm saying they mainly turn up in calculator papers. Who knows? Don't only revise these using a calculator. Make sure you can do some of these without a calculator too. Okay, let's try this one. So I've got 2.9 times 10 to the power of negative 3 times 4.8 times 10 to the power of 4. Okay, now this one I'm multiplying them all together. I'm going to be a bit clever. I'm not going to change them out of scientific notation just yet. I'm going to try and simplify things a bit first. So I've got 10 to the power of minus 3 times 10 to the power of 4. Now remembering your laws of indices, if I just add these together, negative 3 add 4 is 1. I've got 10 to the power of 1. Another way to think about it is, remember that 10 to the power of negative 3, that's going to shift your number 3 place value places smaller. And then 10 to the power of 4 is going to shift it 4 places bigger. So if you've gone overall 3 places smaller and then 4 bigger, overall you've gone 1 bigger. So that's just the same. Multiplying by those two is the same as times them by 10. Okay? So really I've got 2.9 times 4.8 times 10, which is just 2.9 times 48. Okay? Now I'm going to split this up. So I'm going to do 2.9 times 40. And I'm going to do 2.9 times 8, okay, and then add them together. Remember 2.9 times 40, that's like times them by 10 and 4. So that's really 29 times 4. Easy peasy. Times them by 10 gives me 29, and then I'm going to times by 4. And 9 times 4, that's 36. 2 times 4 is 8. Add on the 3. I've got 11 there for 116. 2.9 times 8, that's a 9 by the way. 9 times 8 is 72, making sure my decimal points are all in a line. And 2 times 8 is 16, add on the 7 is what, 24? Yeah. No, 23, what am I saying? Okay, and now I just need to add these together. So one more wee chimney sum, can I fit it in here? 1, 1, oh, let me just, I'm going to be very bad and not put one number per box. I'm going to put 116 and 23.2. Let's make that 0.0 there. Tut tut. 0 add 2 is 2. Make sure my decimal points are in a line. 6 add 3 is 9. 1 add 2 is 3. 1 is 1. So I've got 139.2. Okay. And if you did kind of estimating here, like 2.9, that's pretty much 3. 48 is pretty much 50. So it's like I've almost got 3 times 50. I'm just a bit shy of 3 times 50, which is 150. And this is around about 140. So that's, you know, using that estimate, I can say that's pretty good. Okay, so now that's 1.392 times 10 to the power of, well, a unit would have to move 1 2 places bigger, 10 squared. Okay, let's try doing this one last divide. Okay, and then we'll have a look at an exam question. Okay, I'm going to just, in fact, move this exam question down a little bit. It's not, oh, there we go. Just to give myself a bit more room. Okay, so here I've got 3.48 times 10 to the power of 4, and I'm dividing by 5 times 10 to the power of 6. Okay, so it's like I'm dividing by both things in the bracket. So I've got 3.48 multiplied by 10 to the power of 4, and I'm dividing by 5, dividing by 10 to the power of 6, because I'm dividing by both of these. Okay, now let's do our wee trick again. So this multiplying by 10 to the 4, that's going to move us 4 places bigger. Dividing by 10 to the 6 is going to move us 6 places smaller. So overall, my effect is I'm going to move 2 places smaller. Okay, so I'm going to have 3.48 times 5, and I can write that as times 10 to the power of negative 2. Okay, remember your laws of indices as well. If you're dividing with indices, it's like I'm taking away 4, take away 6, that's negative 2. So I'm going to do this, why have I written multiplied by 5? It's dividing by 5. I'm going to do my easy bit first, that's my decimal division, and then I'm going to shift it 2 places smaller. So I need to do a bit of working off to the side for that. I can't do that in my head. So I'm asking myself, what's 3.48 divided by 5? Well, 5 into 3 doesn't go. 5 into 34 goes 6 times with 4 left over. 5 into 48 goes 9 times with 3 left over. Remember just adding on zeros here at the end. And 5 into 30 goes 6 times. So I've got 0.696. Okay. Just put in my equal signs. Times 10 to the power of negative 2. So I'm moving this 2 places smaller. So it's going to be 0.0069. Oh, I've got 6. Okay. Or 6.96 times. Now from the units column, that's been moved 1, 2, 3. So times 10 to the power of negative 3. Okay. Easy peasy. Now let's have a look at how these questions tend to turn up in exam asked papers. Okay. Now this is a calculator question. You could use a calculator for this, but it's kind of almost the trick is knowing what calculation to do. Okay, and it's like you read this, let's read it and then we'll have a discussion. So a pollen sample weighs 12 grams and contains 1.5 times 10 to the power of 9 pollen grains. Calculate the weight of 1 pollen grain in grams. Give your answer in scientific notation. Now, the fact that this is such a tricky number makes things really, it makes it much harder for you to think, what calculation should I do? Okay, so what I kind of like to do is just, let's ignore that. Let's say a pollen sample weighs 12 grams, and this is not scientifically accurate, and it contains 2 pollen grains. So I've taken that tricky number away and I've made it something much, much simpler, a 2. And then it says calculate the weight of 1 pollen grain. And now this makes this a really easy question. I've got 12 grams, and that's splitting between 2 grains. So to do this easy question, I would just do 12 divided by 2. Okay, now this is a calculator question, so you've got a calculator to do this. So instead of doing 12 divided by 2, I'm going to do 12 divided by 1.5 times 10 to the power of 9. And remember, for scientific notation, I've got to put that in the bracket. See, if you didn't put that in a bracket there, you would get the wrong answer. Okay, that's a 9. Okay, so you would do that in the calculator and pop your answer in scientific notation. So that's my one wee trick for exam questions, is get rid of the tricky number, just make it a 2, okay, or a 3, something that kind of makes sense. Okay, and then think clearly what calculation should you do, and then go back to the trickier number, okay, because this is a calculator question. All right, and make sure you put your scientific notation numbers in brackets.